Hello Science Alliance, welcome to IGCSE Physics, Solids, Liquids and Gases, Lesson 1. Lesson 1! That means we are now ever so slightly over halfway through our IGCSE Physics course. Amazing! Right, so we get to learn about density and volume. This is a bit of a weird one because if you're watching on catch-up, you probably don't know this because you wouldn't be watching everything I've done in order, but over in our flight lessons, we're doing all ages flight lessons at the moment, we've just done density and I set them a task and I was really proud of it. So I'm going to give you the same challenge and then say you have to watch that all ages flight lesson. It was the second lesson on hot air balloons to find out the answer. So what you've got to do is, if you've got a bowl of water and a Lego brick or a few Lego bricks, all you do is, your challenge is, you've only got as many regular Lego bricks as you like no bits with metal attached or anything like that, and a cocktail stick or similar tiny little stick. Can you try and get your Lego bricks to sink in water? Can you do it? I mean, some people had Lego bricks that just did sink, but most of them won't. If you put a Lego brick in water, you can shake it around, you can turn it upside down, you can't get it to sink, except you can. There is a way, but how? So this is a really good introduction to our lesson on density. It's a good challenge. You can use as many of these regular old bricks as you like, you can stick as many together as you like, and yeah, if you find it useful to use a cocktail stick, you could do that. But you know, I'm going to be really mean. I'm not going to tell you the answer. You have to watch this lesson, this all ages lesson on hot air balloons, to find out the answer, okay? Because we're at GCSE level now. We have to move on. We have things to do. But this is why it relates to density. We've really got to think about density if you think about why things float or sink. So first of all, I thought, how have you used the word density in everyday life? I don't use the word dense very often. I'd like to make bread. So sometimes I might say something like, oh, bakery bread is light and fluffy. Mine's quite dense. So a picture here of a very squished loaf. Like, what actually is density? You might, if you're into geography, have heard of population density. The population density of France is 118 people per square kilometre. So I don't know if this is not to scale. I'm not even trying. But if you put a square kilometre on France, you would on average have gathered 118 people in your square. Whereas in the UK, on average, there's 280 people per square kilometre. In London, the population density, as you'd expect, is much higher. Per square kilometre in London, you will find 5,600 people. And I knew you were going to ask, the city with the highest population density in the world is Manila, which is the capital of the Philippines. In 1 square kilometre there, an average of 43,000 people will be living. 43,000 people! In France, 118. In Manila, 43,000. Right, so what does density actually mean? Well, that's quite a good warm-up. You can think of density as being how close together the particles in a substance are, or a better way at this level to think of it is the amount of particles per bit of space. So you picture a brick. Again, if you've just watched my lesson on flight, we will move on quite soon. But if you look at a brick, the particles are quite tightly packed together, right? So you'd say that was quite dense. Water, the particles are a little bit more spread out. So you'd say it's less dense. Air, particles are very spread out, not very dense at all. And another way of thinking about it is how many particles per bit of space have you got? So if you get a 1 centimetre cube and you imagine that that's inside the brick, you've probably captured a lot of particles, right? There's a lot of particles per this centimetre cube. If you put that centimetre cube box in water, there would be fewer particles in there. And for a gas, in general, there's even less particles. Not very dense at all, isn't a gas? Right, and then in our all ages flight lesson, I asked this frankly brilliant question. Which is denser, a single brick or a brick wall? Imagine the brick wall just being lots of single bricks stacked on top of each other. Don't worry about cement or anything like that. Which one of these is denser, single brick or brick wall? And not many people got it, which obviously as a teacher I was delighted by. The answer was, they're both the same density because the particles are the same distance apart in both. It doesn't matter if you've got like a block of aluminium the size of a house or an aluminium can. If you just take a tiny sample of that aluminium and you look at how many particles you've got per that tiny sample, it'll be the same amount of particles, right? If you imagine that see-through centimetre cubed going into a piece of aluminium the size of a house or a piece of aluminium the size of my hand, it would still be the same amount of particles because aluminium just has its particles a certain distance apart. Is that okay? Right, let's play. It's not a game, it's just 3 questions, but you know, you got to try, haven't you? Let's play which box is more densely packed. We're using sweets instead of particles because they're just more interesting. I've got 2 centimetres cubed here, like a centimetre cubed, and then another one. One of the boxes has got 1 sweet in, one of them has got 2 sweets in. Which of these boxes is denser? Which is the most densely packed? In other words, which box has the most sweets per cubic centimetre? So hopefully you are saying it's the one that's got 2 sweets in, because the first one's only got 1 sweet per cubic centimetre, and the second one's got 2 sweets per cubic centimetre, so same amount of space, more sweets. This one is denser. All right, the second one, you've got a centimetre cubed with 1 sweet in, and you've now got 4 centimetres cubed, kind of pushed together, and overall that big box has got 2 sweets in. Which one of those is denser? The answer is, it's this one, the first one, because there you've got 1 sweet per centimetre cubed. And here, well, you've got 2 sweets per 4 centimetres cubed, so on average that's only half a sweet per centimetre cubed. So this box isn't as densely packed. All right, last one. Which one of these? You've got a centimetre cubed with a sweet in, and again 4 centimetres cubed stacked together, but this time there's 4 sweets in that bigger box. Which one of those is densest? The answer is, well, this one's got 1 sweet per cubic centimetre, and this one has 4 sweets per 4 cubic centimetres, so it's, on average, that is 1 sweet per centimetre cubed, so it's the same density. Is that okay? Right. So let's dig a little bit deeper because it's IGCSE. When I said density means the amount of particles per bit of space, can we please start building this into an equation? So instead of amount of particles, let's say mass. Now, some of you might have seen our lesson on mass, and we actually learned that even your exam sometimes says mass in 2 different ways. So sometimes they've said that mass is the amount of particles in a thing. It's actually more correctly described as how hard it is to push something. But it's perfectly okay. We will say that mass is the amount of particles in a thing, all right? So it's the amount of mass per bit of space. But a much better word for bit of space is volume. So the equation for density is mass per volume, right? Mass divided by volume. Which, hopefully that makes sense to you. You got a mass, you share it out among certain volumes, that's how dense it is. There wasn't really any reason to flip you around there, was there? Let's carry on. So are you okay with working out the volumes of 3D shapes? You're going to have to do that in quite simply at IGCSE. Hopefully most of you are okay with how to calculate the area of a square. So for example, if you've got a square that's 1 centimetre by 1 centimetre, then the area of it is, be careful, whatever you do to the number, right, in any equation, you have to do to the units as well. So obviously 1 times 1 is 1, and a centimetre times a centimetre is a centimetre squared. So the area of that square is 1 centimetre squared. So the volume of a cube, you do the same thing, right? It's 1 centimetre by 1 centimetre by 1 centimetre, which gives you 1 again, but this time it's centimetres cubed because you've times 3 centimetres together. All right, we'll go pretty fast. I mean, I feel like you're probably okay with this. So the volume of this shape, you would do 2 centimetres times 4 centimetres times 1 centimetre, which gives you 8 centimetres cubed. Whew! Right, so mass is usually measured in kilograms. Volume is usually measured in metres cubed. What is density usually measured in? Come on, you know this. We've done a lot of work with equations. If this is your first time, well, you might not be able to work this out. What's the unit of density? Look, remember, everything you do to the numbers, you have to do to the units as well. So if on this side you're doing mass divided by volume, you're doing kilograms divided by metres cubed. So the units of density, drum roll please, are kilograms per metres cubed. I know, right? Kilograms per metres cubed. Obviously, grams per centimetres cubed might be more sensible. It's perfectly okay to write that in an answer. Just make sure you write whatever the units are. You stipulate, okay? So I've just to really double down on this, whatever you do to the numbers, you do to the units. So you probably know that 12 divided by 2 is 6. So 12 kilograms divided by 2 metres cubed is going to be, well, the number is still 6, but this time you have to add units, and it's kilograms per metres cubed. All right? Phew, right, one last piece of information before I give you something to do. You're probably familiar with measuring cylinders or measuring jugs. This is how you measure volumes of liquids in a lab, say. 1 millilitre is the same as 1 cubic centimetre. There you go. Hopefully, if you didn't know that, you do know. No, 1 millilitre on the side of a measuring jug is the same as 1 cubic centimetre. Okay, now you can do the questions. Phew, here we go. Here is a cube of aluminium. It's 2 centimetres by 2 centimetres by 2 centimetres. It has a mass of 21.6 grams. What is the density of aluminium? A 20 millilitre tablespoon of golden syrup has a mass of 30 grams. What is its density? Remember, you can really use any units you like as long as the units are the same on both sides of the equation. And number 3, water has a density of 1 gram per centimetre cubed. What is the mass of 75 cubic centimetres of water? You've got the equation here, density equals mass divided by volume. Number 4, a super tough one, I'm not looking forward to explaining this. Give your answer for the density of aluminium, whatever you got in question 1. Can you give it in kilograms per metre cubed, please? And number 5, bit of brain exercise for you. How would you find the volume of this bronze statue of a very irregular, solid shape? How on earth are you going to find the volume of that? How much space it is taking up? I'm going to draw something on the board to help me explain question 4. How are you getting on? Should we go through it? So this cube, well, first of all, you've got to work out the volume, which is 2 times 2 times 2. So it's 21.6 grams divided by 2 centimetres times 2 centimetres times 2 centimetres, which is 21.6 grams divided by 8 centimetres cubed, which gives you 2.7 grams per centimetres cubed. Make sure you write the units on, doesn't mean anything without the units. A 20 millilitre tablespoon of golden syrup has a mass of 30 grams. What is its density? Did you remember that millilitres is the same as cubic centimetres, so you might want to have converted it, but you didn't have to. So 30 grams divided by 20 cubic centimetres is 1.5 grams per centimetre cubed. Or you could have put grams per millilitre, that would be fine, as long as you'd written it the same on both sides. And water has a density of 1 gram per centimetre cubed. What is the mass of 75 centimetres cubed of water? Well, you do mass equals density times volume, okay? You've got to do some rearranging. So mass is density times volume. And that gives you, so your density is 1 gram per centimetre cubed times 75 centimetres cubed. So it's just 1 times 75, right? So it's just 75 grams. Isn't that weird? But it's true. This is very helpful if you are ever baking. I'll show you. So if you've got 200 millilitres of liquid, 200 cubic centimetres, well, water weighs 1 gram per cubic centimetre. So, oops. So if I put this to 0 and we weigh how much water is in here, it should. Obviously, my measuring jug isn't very precise. Come on! That's pretty good, isn't it? There you go. So it weighs almost exactly 200 millilitres. Right. And can I just to, I know we harp on about this a lot, but it's really important that you get used to checking your work. Here, come a little bit closer for me. If you're not quite sure about rearranging equations, if you're worried that you haven't rearranged your equation correctly, let's have a look at this. So you did mass equals density times volume, right? The symbol for density is, I think it's called pho. It's like this little p, but it's not quite a p. So it's density times capital V for volume, right? And you said it was, you said the density was measured in kilograms per centimetre cubed. I'm just going to draw it like that. Is that all right? Kilograms per centimetre cubed, kilograms divided by centimetre cubed. And you've times it by volume, which is just measured in centimetres cubed. So what unit pops out of that equation? Well, can you see that if you're timesing something and dividing it by the same thing, then that just cancels out. So here your centimetres cubed will cancel out. If you're dividing and timesing, that's just the same as not doing anything. So you're left with a unit of a gram. And is a gram a reasonable unit for mass? Yes, it is. So especially if you're in an exam and you're really nervous and the time is ticking, that's a really good way to work out whether you've rearranged your equation correctly. Just have a look at the units. Okay, right, let's do question 4 then. So you've got this, this value, 2.7 grams per cubic centimetre, but you want to convert it into kilograms per metre cubed. So what do? Well, we've done a bit of converting from grams into kilograms before, okay? There's 1,000 grams in 1 kilogram. So first of all, let's just convert grams to kilograms. There's 1,000 grams in 1 kilogram. So if you're changing from grams to kilograms, the kilogram number is going to be a lot smaller, right? 1,000 grams in 1 kilograms. So you divide by 1,000 here. So to divide 2.7 by 1,000, you move your decimal place back, right? So we've got 2.7. If I move my decimal place back 1, I've divided it by 10. Again, I've divided it by 100. And again, I've divided by 1,000. So let's put the decimal point there. Stick some zeros in. Phew, and say that we've now divided 2.7 by 1,000 to get it in kilograms, and we've got 0.0027 kilograms, but it's still per centimetre cubed. Whew, so now what do? Well, how do you convert from centimetres cubed into metres cubed? This is where it gets a bit tricksy, because if you were just trying to change something from centimetres into metres, there's 100 centimetres in 1 metre, right? So if you're converting between centimetres and metres, you could just divide or times by 100. But you can't do that when it's cubed. So we've got centimetres cubed, and we want to change that 1 little centimetre cubed into a metre cubed. So what do? This is why I drew this very sloppy diagram on the board. Imagine you've got 1 centimetre cubed, here it is. If you times that by 100, then all you've got is like, what you have to do is you have to times it by 100 3 times. Because if you times 1 centimetre cubed by 100, you've only got like one long line of them. This is the way that I think of it. If you times it by 100 and then you times it by 100 again, then you've turned that 1 centimetre cubed into like one face of a square. So 100 centimetres cubed, but you need a metre cubed. So you need to times it by 100 and then times it by 100 again and then times it by 100 again. I'm not really convinced by how I've described that. I hope it makes sense to you. I've said to the others on Facebook, I will put in the usual homework PDF that goes up in my Facebook group. I'll put a load of resources in so that you can practice converting between metres cubed and centimetres cubed and things like that. But that's what I have to think of. So you have to times it by 100 and then times it by 100 and then times it by 100 again to go from 1 centimetres cubed to a metre cubed. So let's times it by 100. So we go forwards 2, times it by another 100, we move that decimal point another, forwards another 2, and then times it by 100 again, we move it another 2, and what we end up with is 2,700 kilograms per metre cubed, which if you look it up, is the density of aluminium. Well done if you followed that, well done if you didn't follow that at all, but you're still here. Right, how do you find the volume of this bronze statue? This is so lovely. This is what Archimedes did before he shouted, Eureka! I've got it, maybe just after. You could get this little statue and you could stick it in some water. And then however much the water goes up, well, that's the volume that little thing is taking up. Do you see what I mean? So this, obviously, the particles in this statue are taking up the space that the water was taking up. So you displace the water has to move. So the water level of the jug goes up. And if you can measure the difference between the water level before and after that little chap's gone in, then you've got the volume of that little chap. Does that make sense? Good, eh? So this is in your specification that you just have to know how to work out the volume of irregular shapes that sink. You don't need to know how to work out the volume of irregular shapes that float. That's too complicated. But you do need to know the ones that sink. I'm trying to. Oh, here we go. Yeah. So, for example, if I've got a measuring jug here and it says, what does that say? It almost says 300, doesn't it? That'll do. And I want to work out the volume of this jug. I can't measure it, can I? I can't get a ruler because it's just incredibly complicated. But if I put it in the water, there we go. It's obviously got to be completely submerged. The whole cup has got to push all the water out of the way. Then, yeah, you can see the volume has gone up. So the volume of this cup is, I don't know, how much has that gone up by? Pretty much exactly 50 millilitres. So the volume of this cup would be 50... Wait, that's not right, is it? I'm thinking 50 cubic centimetres. That is absolutely not right. 25, 50... Yeah, 50. Seems smaller. Well, there you go. Right, I have a little challenge for you just before you go. I've got a handful of marbles. I actually have. I'm going to do it. I've got a handful of marbles. Maybe you have too if you brought some. Each marble weighs 4.8 grams. I want to know the volume of a marble so I can work out the density. I have a jug of water. But if I just put one marble into the water, it doesn't raise the water level enough for me to take a reading. What am I going to do? Okay, I've got a handful of marbles. Have as many marbles as you like. You've got the weight of, well, I should say the mass. That's terrible, isn't it? You've got the mass of one marble. So if we know the volume of the marble, we can work out the density. But if I just put one marble into this water, it's not making enough of a difference to the reading like, you know, just the scale on my jug is not enough, right? I can't tell whether that's gone up by 1 milliliter or 10 milliliters or whatever. What are you going to do? Can you solve the problem? They did very well with this on Facebook. I was very impressed. Have you got it? I think it's quite tricksy, this. Okay, what you've got to do is, you've got to put more marbles in the jug, right, to displace more water, and then just work out the volume of the amount of marbles you put in, and then times the mass. Wait, come here. Do you get it? You've got to put more marbles in, and then if you put like 6 marbles in, you know the mass of 6 marbles because you just times 4.8 by 6. So you've got the mass of whatever, how many marbles you've put in the jug, and you've got the volume that those amount of marbles have displaced. So then you can work out the density, because the density of like 20 marbles is the same as the density as 1 marble, right? Okay, let's do it. Let's have a look here. Here we go. Have you noticed, by the way, this could come up in your exam, that whenever I'm reading off the side of a measuring jug, I'm always getting right down next to it, because look, if you're looking up from above, the level seems to go down, doesn't it? If you're looking from below or above, it changes. So always make sure that you're looking directly on. In fact, now I am. I can see that I need to add a little drop more water. So I've got it to, I think that's pretty much exactly 300. And then I'm just going to add marbles until I've displaced a reasonable amount of water. What do you reckon? Is that 300? Yeah, perfect, right? Okay, so let's put in 1 marble isn't going to make any difference. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, see, yesterday when I did this on Facebook, I said that 11 marbles displaced 25 millilitres. I don't think that's quite right, actually. I'm going to put in 12. Even 13. Do you reckon even 14? Maybe even 15? All right, I think 15 marbles. If you have brought a calculator, you can do this with me, because actually I don't have a calculator. I think 15 marbles have displaced 25 millilitres of water. I'll write this down. You can too, if you like. 15 marbles have displaced a volume of 25 centimetres cubed. So the mass of 15 marbles will be 4.8 times 15, right? Let's do that. So 4.8 times 15 is 72. So the mass of all the marbles in there is 72 grams. So the density is going to be the mass divided by the volume, right? So 72 grams divided by 25 centimetres cubed. Let's see if this is going to work. Oh, and the answer that I get is 2.88, a density of 2.88. And if I look up now the density of glass, because marbles are generally speaking made out of glass. I don't know for sure that these ones are made out of glass. It might be something else, but I reckon that's going to be ballpark. They have a density of 2.5 grams per centimetre cubed. It's not bad, is it? to say that I was using pretty shoddy equipment. There you go. So I got a density of 2.88 for my marbles, and the density of glass is 2.5, and I'm not entirely convinced that this marble is totally made of glass. Most marbles have got all kinds of other stuff in them. So have a go, if you can. Look around your house, find different objects, maybe like a teaspoon or something, submerge it in water, try and measure its volume, work out its density, if you can weigh it, and then look online and see if you're right. Very good practice. Right. That is the end of the lesson, except I've just got one question for you before I go away and set you some homework to do. See how well your brain and your memory are working. My question is, can you tell me the city in the Philippines with the highest population? That's just your only question for the end of the lesson. Can you tell me the name of the city in the Philippines with the highest population? Can you tell me the name of the city in the Philippines with the highest population? While you're mulling on it, I'll go to my Facebook page to see if anyone said hello. I caught them all out on Facebook with this one. All of them. Every single one of them I caught them out. Not a single person commented the correct answer. Can you tell me the name of the Filipino city with the biggest population? The answer is no, you can't, because I didn't mention the name of that city. I told you about Manila, which is the city with the highest population density, but actually Manila is only the second most populated city in the Philippines. Yeah, it's not the city with the biggest population. That's a different city. This is just the city where the population is living the closest together, right? So the densest thing isn't necessarily the biggest thing. Is that okay? Oh, I was proud of myself for that yesterday. Loads of people saying, Manila, Manila, haha, I remembered. And one person said, I don't know. And I was like, you're right. Anyway, sorry, overload of smugness there. Okay, let's see if anyone's... Oh, all right, Henry, you're giving me some answers. Henry's just giving me loads of answers. Sweet boxes, right, left, same. Good. Bonus question. Put enough marbles in to see the difference and divide the volume, get the nut easy. Oh, well, okay, good. Oh, come on! You even looked up the city in the Philippines with the highest population. Oh, that is beautiful. Oh, okay. So Henry has said for the sinking Lego thing. Henry, I don't think you come to all ages, do you? For the sinking Lego puzzle, make a tall tower of Lego so that it has a small surface area but a high density, causing it to displace enough water for it to sink. No, that is not the answer. No, you can make a really, really, really tall tower out of Lego, but we haven't mentioned surface area once, haven't we? We haven't talked about surface area. It isn't surface area that makes things float or sink. It isn't surface area that causes it to displace enough water. So you could stick loads that she says bravely. I've just piled a few of them together. You will find that you can stick as many Lego bricks together as you like. If it doesn't float, if it doesn't sink, then it doesn't sink. Because otherwise, like ships wouldn't work, would they? One piece of wood floats. You put all those pieces of wood together to make a ship, the ship still floats. I mean, actually, that's a bad example. We've gone into A-level physics. But anyway, no, that isn't. Do you want me to tell you? Should I tell you? It's just like we did do quite a bit of it with diagrams and stuff in the flight lesson, and it was really useful. Okay, Henry's given me some more answers. This is very good. The answer was that you've got to take the air out, because air is not very dense at all, and overall the Lego brick has trapped so much air that the density of the brick and air combined is less than the density of the water. So things that are more dense sink, right, and things that are less dense float. So hot air, we've looked at this. In fact, I will come back to my worksheet, because I even made the worksheet and I spent ages on it, and I should show you. Not ages, but... We've looked at this already, right? If you've done my convection lesson, we looked at how air particles above a radiator, they're cold, the particles are close together, and they gain energy. So what happens? Well, those warm air particles, they spread out, right? They become less dense. We've looked at how warm air is less dense than cold air. Its particles are more spread out, and that is why they rise up. And that's the same with everything. Stuff that is less dense rises. So what you've got to do is get the air out of your Lego brick. So this Lego brick floating, and when you turn it upside down even, you can see, right, there's loads of air trapped inside that brick. So if I can't fit in. But if you get in here, the only way that I've found to do it is to hold it under the water. And it takes ages, actually. You've got to be really careful with it. But if you hold it under the water and you have a good wiggle inside all the little Lego holes with your cocktail stick, you've even got to go around the outside because there's other little holes that trap all the air. Then overall, you're making the Lego brick more dense, right? Because what was now air is now water, and water is more dense than air, okay? So I really do explain this beautifully in the All Ages Flight lesson with diagrams, because we haven't done anything about floating and sinking, because I wanted you to go and watch that lesson. But yeah, if I've done it correctly, if I let go of that, no, it's still some trapped. Henry, what have you done? What have you set me off on? Turn it upside down. Give it a good wiggle. God, this is brilliant telly, isn't it? It's because there's still air bubbles, chaps. Yeah, I'm still getting them out. There you go. Whew. So that's how you do it. So, I don't know, my nerdy brain was absolutely delighted by this. That it turns out that the plastic that they make Lego out of is more dense than water. So it will sink, but it traps so much air that overall the density of the brick is less than the water, so it floats. But as long as you can get the air out, then it will sink. Right, on that dramatic bombshell, I will go. I will see you next week when we're going to be learning about, I think we're going to be doing pressure next week, like whether it hurts more if an elephant steps on your foot or my 5-year-old wearing high heels. Not that they do, but you know what I mean. We're going to look at like the science of biscuit cutters. It's one of my favourite lessons. I will see you next week. Thank you so much for coming. If you want to support me, you can. If you want to support me, go to my About section, click the website, link to coffee. Go to coffee. Just search Theatre of Science Coffee, but actually don't do it yet. If you're watching live, don't do it yet, because I'm going to do a little Black Friday thing where you get a thing for free. So if you've been thinking, I really should be supporting Lara for the vast amount of work that she's putting in, then you totally should, but do it on Friday. Don't do it now, or you'll be annoyed on Friday because you could have got the free thing. Okay, see you soon. Bye.